In this video, I am going to demonstrate the use of the kinematics model in the vertical direction. So objects that fall under the influence of gravity. So here we have a cliff here, and somebody's going to throw an object downwards at a given velocity. We have to find a couple things. So here's an object, and we're going to throw it down. And we're going to throw it downwards with a velocity of 11.7 meters per second. So I'm going to say the initial vertical velocity, the velocity in the y direction, initially is, now because it's downward, I'm going to say it's a negative 11.7 meters per second. There's actually three different cases. If I were to throw it upwards, this would be a plus 11.7 meters per second. If I throw it downwards, negative, consistent with positive or negative signs on the y-axis. And if I were to drop it, it would be 0 meters per second. So it's starting from rest. Okay. So in this case, I'm throwing it downwards. The height of the cliff is 26 meters. So I'll say 26 meters is this distance right here, from top to bottom, 26 meters. Okay. And we have to find a couple things. A, we need to find the time it takes for the object to go from that 26 should actually be right up to here, where the objects drop from. The time to fall, and then also the velocity right before impact, right the instant right before it hits the ground. So we're going to find these two quantities. So in the vertical direction, the kinematics equations are y equals y0 equals vy0t 1 plus 1/2 ut squared. Notice how there's plus signs here for all these quantities, just like the x kinematic equations in the x direction. Final velocity equals initial velocity plus gravity times time, and the final velocity, initial velocity, and 2 times gravity times the change of position. Okay, so these are very similar to the x equations. We just substitute y's for x's, consistent with the y-axis, and we subscript the y's to make a to ensure that we're talking about y velocity. So the variables. Again, we have a pattern here. We say initial final position or displacement, initial velocity, final velocity, g, which is the gravitational acceleration, in time. Okay, so I'm going to write these here. All right. So when we do these problems or any kinematic model problems, we imagine that we have a xy axis where the motion begins. So we overlay xy axis here, and I do that to say that the motion begins at the origin, or where it originates from. So if that's the case, y0 is the origin. It is 0 meters. And when it falls downwards here, this cliff is 26 meters high, but from a mathematical point of view, when it falls downwards along the y-axis, this is actually going to be negative 26 meters. In other words, if I were to plot this point on the y-axis, for the y-axis we're coming down here, I say this would be 0, minus 26. So you can see we're creating a mathematical model or version of the motion here. The initial y velocity we said is negative 11.7 meters per second. Negative because it's going downwards, and we use a j to denote the direction. The velocity right before it hits the ground, we don't know. Okay, I'm pretty sure it's going to be negative, but I don't know the quantity, so I'll just leave a box there. Okay. G is the acceleration due to gravity, and it's negative 9.8. It's a vector that points downwards. Meters per second squared. Okay. J, it's the quantity that makes the velocity increase downwards. So it's actually, if you want to draw it here, it's a vector that points downward like this, and that causes the velocity to get greater in magnitude. How long does it take? I'm not sure. We don't know. We need to find that. Okay. So we need to find the velocity and the time. Velocity and time. So let's go to the solve part. So the solve part, let's say A here. And I should make a note here. We should always number these. Step 1, list equations. Step 2, list the variables. And step 3, solve. Okay, I should probably put that in my template. So for the time here, so once we have the variables here, which is arguably the most important point, we can go ahead and look at the equations and find out what equation to use. So if I want to solve for time here, let's see, I know g, I know the initial velocity, I know everything here. The only unknown is t, so I could use this equation right here. This equation is not usable because I don't know this velocity. Okay, I probably could find the velocity from this equation, which I need to find anyways, and then plug it into here to find the time. Okay, right now I'll use this equation right here. So I'll go over here and I'll say that y is equal to y0 plus vy0t plus 1/2 gt squared. Okay, so this is a quadratic. We have a t term and a t squared term. And again, to get this into the proper quadratic formula, I'm going to say 1/2 gt squared. I'm going to rewrite this plus vy0t plus y0 minus y, because in the proper quadratic form I need to have this all equal 0. So there's my a coefficient, there's my b coefficient, and my c coefficient for the quadratic. So 1/2 9.8 is negative 4.9. That's a in the quadratic formula. B is negative 11.7. That's B. And C is, now we gotta be careful here, this is 0 minus 26. So C is actually plus 26. Okay? If you use the quadratic formula and solve for time, you're going to get two roots. You're going to get negative 3.78 and positive 1.4. So since time can only be positive, we're going to say that the positive root is the amount of time it takes for it to ground. So that's the answer to part A. Part B, I'll go up here in part B. On your homework, you should probably have some space below it. We want to find the velocity right before it hits the ground. Okay. So now that I know time, right here, now that I know time, and I know the initial velocity, I can use this equation right there. I can say Vy, the velocity right before it hits the ground, is equal to Vy0. Okay, notice I'm starting with the general equation and showing the flow here. Negative 11.7 plus a negative 9.8, that's g, times 1.4 seconds. And if I did this right, this is negative 25.42 meters per second j. That's the velocity in the y direction. And it's a negative, which is consistent with the fact that it's moving downwards at that point. The instant before it hits the ground, it's moving downwards with the y velocity of that negative. In the homework in web assignment, you might be asked for the speed. The speed is simply the magnitude of the velocity. The speed in the y direction is the magnitude. So it's simply the 25.42 meters per second. It doesn't have the minus j. It's simply the magnitude. Okay. So depending on what's asked for, the velocity of the speed, you would type the correct answer in the web assignment. So this is a sample of how you would complete a kinematics model problem in the vertical direction. We have a diagram where we list quantities that we know. We list what we need to find. We have these equations here. Okay, make sure we list them in this order. We have the variables in this order. Okay, and then we have the solve, where we found time and the velocity. So, simple example of a kinematics model in the vertical direction.